Okay, welcome to a semi not quite live stream. I thought I was going to make a quick live stream, but then I decided not to torture you with it. It's a snowy Sunday evening here, and yeah, that would be snow coming down. Okay, so I was going through some of the memes that I found on Twitter and I came across this one. Someone was thinking, this can't quite be right for some reason. They're both about the same size, and yet why does reasons? Well, anyways, so I thought I would analyze this and see what I could tease out of it. So the first thing I did was got rid of some of the stuff around the the two actual pictures, and I started with the one on the left like that. Then I drew a circle on another layer and then removed the necessary stuff to kind of give an outline of the entire moon, with the idea that I would measure the diameter of the moon. So this is pretty much a reasonably good fit that I could make of it. Took the entire measurement and registered 1,179 pixels. I then zoomed in and did something similar for the length and the width of the ISS. And I got 25 pixels for the length of the ISS like this, and I got 18 pixels for the length of the solar panels. So the next thing I did was I copied this image in another layer, moved it to the left, did something similar so that I could get the measurement of the moon's diameter like this. Again, these are somewhat estimates, and I came out with 1,127 pixels. So I went online and grabbed the official values, 384,400 kilometers away, with a moon diameter of 1,737.4 kilometers. From that, I calculated the moon's angular size, and with each of these, I calculated their respective pixels per degree. Given that the ISS is at an average height of 420 kilometers, I worked out what the angular size for the ISS's length and the angular size for the ISS's width should be. Then I calculated the estimated distance. This would be line of sight from the photographer to the ISS. Derived an average for that. And I calculated, or I estimated, the camera's altitude, and I figured that the camera should have been at an altitude of about 37.4264 degrees, or 0.4265 if we want to round up. I decided to do some calculations in reverse. Given an estimated distance. I recomputed the angular size of the length and the width, and then using the pixels per degree, I then recomputed the estimated pixels that it should have been in the image, and they do seem to match. For the airplane, even though I put down the body of measured 9 pixels and the body plus the tail wing at 15 pixels high, I'm not using either of these. I'm doing a similar calculation. I estimate the angular size of the length of the airplane's fuselage at 0.024816 degrees. From that, I estimated how far the airplane would have been from the photographer if it was flying at, let's say, 11 kilometers high. From there, I recomputed the angular size of the airplane's fuselage, that is, and then reconverted to an estimated pixels. And in this one, I did something similar. I estimated that the moon and the airplane would have been 3.86 degrees altitude. So that's basically going to be it for this one. I just thought I'd share that with you, and I might end up redoing this at a later time, maybe if I'm too bothered to cut it up and edit it and remove the hems and haws and the dead time like this. All right, I'll see you later. Bye.